Alright guys, in our second video we're going to I guess get some understanding of what the net force is. Because remember the first law of Newton, you pretty much got the object with F net is equal to 0. But what does it mean? Alright, so I gave you here several examples on how to figure out the net force. But before I proceed with these examples, I want to give you some sense of what force is, and later on I will derive the meaning of it and also the units. Now, the force pretty much is a push or pull exerted on the object. Now, anytime you have an object that is pretty much going with the constant velocity, zero acceleration, that means there is no net force applied to it. But anytime when this object has a constant velocity and velocity now starts increasing, and so does the acceleration, now there is some external force applied to the object. Now, let's take a look at the first example. Let's say I got these two individuals, pretty strong individuals. They are fighting for, something like, I don't know, something that they want to have, each of them, and they're trying to pull that object one from another. And so one person pulls, let's say, with 100 newtons, and the other person pulls the opposite direction. So again, force, what I need to mention, it's a vector. So what does it mean, it's vector? Well, it has a direction, has a magnitude. So in this case, one person pulls it this way, with the same magnitude the other person pulls the other way. But remember from our previous discussion how we added the vectors. And so the way we added the vectors is that we took the first vector pointing to the positive direction, plus, and then since the other pulling in a different direction, in the negative direction, if we imagine here the coordinate system, this is the plus, this is the minus, and so we can just say that FA vector plus, we always add the vectors, plus negative vector AB, because it's pulling in the opposite direction. And so the resulting vector here, and I just put one below the other, is showing us that it's pretty much 0. And I just substituted the numbers for each vector, and also I included the sign, and so I got now the force net that is 0. So in this particular case, when one person is pulling with 100 newtons and the other one is pulling in the opposite direction, the object that they're pulling is not moving anywhere. And so this body is at rest, it's equilibrium. There is no change in velocity, no acceleration is 0, and so the net force here is pretty much 0. Now, in my next example, I have two individuals. Let's say they have some kind of a box, and they're pushing this box together in the same direction. So what is the resulting force here? And the resulting force, of course, will be our F net force, net force. And in this example, since the pushing in the same direction, I have to add one vector plus another vector, they in the same direction. And so remember, guys, how we added the vectors. We, again, the resultant vector, or net, F net, will be from the tail of the first vector, go all the way to the head of the second vector. And that's our F net right here. This from here to here. Now, so again, I added the vectors, I plugged the numbers in, I got 200. So in this particular case now, the acceleration, if they're pushing it to the right, the acceleration will be now increasing to the right, because the net force here exists. It's not a 0, and therefore you're going to have an increase in acceleration and also change in velocity. Now, our third example here, it's an interesting one. We have, let's say, two individuals pulling to the right, and one individual is trying to pull the object that they have a tug of war game, I guess, pulling the opposite way. So where is the object gonna go? So again, since force is the vector, it has the magnitude and it has a direction. So this force here is stronger. So I would expect that the net force is right here, plus it's pretty much, it's this side of the vector is bigger than this side. So again, what I'm going to do now is I'm going to add these vectors. But again, remember, the way we add the vectors, especially, when they're in opposite direction, we add them. And what we do for the second vector that is in opposite direction, we just put a negative sign. Okay, so when I did so, my net force, I got here 100 newtons. And here, obviously, the acceleration, you see the resulting vector. I did again this, I flipped this vector. And the resulting F net resulting vector now is from the tail of the first vector to the head of the second vector. And now this F net is pointing to the right direction. And so there we know that now this object will be accelerated to the right and with the change of the velocity.